Hi there, welcome back to Easy Mathematics. We thank God for another opportunity to also bring the end the lesson on change of subject and substitution. Today we want to look at the substitution, that's the final one under it. Then we look at factorization. Now when we say substitution, as the name goes, to change, okay? So we are going to replace the letters with numbers. That is all about substitution. Now, what we should also take note when it comes to substitution is especially the negative numbers. If you are to substitute a variable or the letter you are going to replace the number with, the number is negative, you have to be very, very careful and handle it accurately. So let's look at the first example. So it says that if A is equal to 2, B is equal to negative 1, C is equal to negative 3, and D is equal to 0. Evaluate the following. So you have the first one to evaluate. So we can say solution. We have to evaluate A minus B minus C. So we are going to substitute. We are going to replace the letters with numbers. That has been given in the question. So it says A is 2. So we are going to replace the A with 2. Then minus B. Now the B is negative 1, so we come with the negative 1. Okay, good. Then minus C. C is also negative 3, so we should come with it. So this is going to give you 2 plus 1 plus 3, which gives you 6 as your answer. So anytime you are substituting and you notice that the letter you are substituting has a negative number, you have to come with a negative along. Don't say because there is negative here, then you only bring the 1. No, it follows that order. Now note that when negative meets, it becomes positive. And when negative meets, also becomes positive. And that gives you the answer. Then with the II, you have ACD, which means A times C times D. So what is A? A is 2. What is C? Negative 3. And what is D? 0. So you have 2 times C, negative 3 times D, 0. Now any number times 0 is 0. So our answer is basically 0. So you should take note of that. So that is what? Substitution. So you see, this is very, very simple. Because when it comes to the substitution, you are replacing letters with numbers. So based on the given number, you replace it with the letter that it has been equated to. So A, B, C, D, or ACD means A times C times D. And A from the question is 2. And C from the question is negative 3. And D from the question is 0. And any number times 0 is 0. So there's no need for us to even calculate for this. What you should know is that substitution is simply about replacing letters with numbers. Let's look at the last one under the number 1. The number 1 says the third one is 3a squared minus 2bc. So now you know that 3a squared, it means 3 times a times a. Then minus 2bc, which means 2 times b times c. Very, very important. We should know that as well. Now, from the question, they have been given a condition that A is 2, B is negative 1, and C is negative 3. So we have to substitute so that we do the accurate thing. So we have 3A, and the A is 2. So we have 2 squared because it is A squared. Minus 2 times B. The B is negative 1. Then you have C times negative 3. Now 2 squared will give you 4. So we have 3 brackets of 4 minus, let us solve for this. And we are going to have minus 2 times negative 1 times negative 3 will give you positive 3. So we just have 3. Then this will give you 12 minus 4. 4, 3 is 12. So 2, 3, 6. Which gives you an answer of what? 6. Because 6 minus 6 is 7. 6. So this is negative, and negative times negative is positive. So you work it out. Now this is very simple. When it comes to the substitution, it is very, very simple. Why is it simple? Because we are replacing letters with what? With numbers. Without even evaluating the expression. You just change and solve. But in some questions, you may be asked to evaluate before you substitute. You may be even asked to make a variable the subject before you substitute. But with these ones, you are just substituting. So you replace the given letters with the numbers they are corresponding to. And that is the word, the substitution. Now let's take an example whereby we may be asked to make a variable the subject and also substitute. It says that given the relation 1 over n is equal to the square root of k squared plus a squared all over hg. Express k in terms of n, a, h, and g. Now we were told that once you are being asked to express a variable in terms of other variables, it simply means make k the subject. So if you have this relation, which is, let's say, solution, which is 1 over n is equal to the square root of k squared plus a squared all over hg. You have to make k the subject. In other words, you are to express k in terms of the other variables. Now look at the expression. This expression involves a square root. And what also makes it confusing is that the variable we are to make the subject is inside the square root. Now, because the variable we are making the subject is inside the square root, what do? We have to get rid of the square root. And by doing this, we are going to square both sides of the equation. So we have this and this. So we are going to say 1 over n all squared is equal to the square root of k squared plus a squared all over hn all squared. So now when we square both sides, the square root will now be cancelled out by the square. Now you are having all this square, the square is affecting 1, the square is affecting n. So we are going to get 1 over n squared is equal to k squared plus a squared all over hg. Now remember that 1 squared is the same as 1. So if I've written 1 over n squared, it means I've just squared the 1. Now that we get rid of the square root, remember we are making k the subject. Now that we get rid of the square root, you are having a fraction. What do? You multiply each term by the LCM. And the LCM is going to be NGH. It's going to be your what? Your LCM. Or GNH will be your LCM. Sorry? You have n squared, so it's going to be n squared GH as your LCM. So we multiply this by LCM, multiply this by LCM. So we have n squared GH times 1 over n squared is equal to n squared GH times k squared plus a squared all over hg. So the n squared will be cancelled out, then the hg will cancel gh or vice versa. Then we now have gh times 1 is equal to, remember this has cancelled out, this has been cancelled out, is equal to n squared times the numerator. But the n squared will multiply everything in a bracket. So we put it in a bracket. The n squared will multiply this. So for us to know that the n squared is going to multiply this, let's put it in a what? In a bracket. So that the n squared will multiply this. Then the n squared will also multiply this. So now let's continue. We are making k the subject. So we are going to say GH is equal to n squared times k squared will give you n squared k squared. Then n squared times a squared will also give you n squared a squared. Now you've been able to clear the square root, clear the fraction, expand the bracket, expanded the bracket. Now we are having this where we are making k the subject. Now that we are making k the subject, how do we do it? We are just going to let the term with the k stand alone. So let the k term be here. And this should join the gh. So we are going to say gh minus n squared a squared is equal to n squared k squared. We are interested in the k standing alone, but the k is with a square being multiplied by n squared. So what do? We divide both sides by n squared. So we are going to say gh minus n squared a squared is equal to n squared k squared over n squared all over n squared. So now the n squared cancels the n squared. So we have k squared to be equal to gh minus n squared a squared all over n squared. Again, we are to make k the subject, not k squared. So now that the k is having a square, we are going to square root both sides so that the k can now be expressed in terms of the other variables. So we are going to square root this side, then we also square root this side, all over n squared. So now this cancels out. Now you have k is equal to. So now that you have k is equal to, you have been able to express k in terms of the other variables. Now remember that since there is a square here, don't say the square will cancel out. No. But the square root is for the numerator. It is also for the denominator. So this expression can also be written as the square root of gh minus n squared a squared all over the square root of n squared. So the n squared will now, the square on the n will cancel this. But the squares here cannot cancel the square root. Take note of that. So we are now going to get our k to be the square root of gh minus n squared a squared all over n. So you see, this is a substitution. You see, you have to substitute n is equal to 8 over n. A is equal to 3. H is equal to 2. And G is equal to what? 32. But before we can do the substitution, we have been asked to express k in terms of the other variables. So if we should omit that process, then we are going to get it wrong. Totally wrong. So first, what the person is demanding is to express k in terms of the other variable. Don't begin by what? Substituting. If you have been asked to do something before you substitute. So we have been able to express k in terms of the variables. Now that you have been able to do that, it says, hence find k. So hence using the answer you have whereby you make k the subject, hence it says what? Find k. So this is where we are going to apply the substitute, whereby we will replace the letters with their corresponding numbers. So J from the question is 32. H from the question is 2. N from the question is 8 over 5. A from the question is 3. So here you take your time. But before we look at the substitution, let us quickly go over the making k the subject. Now, first of all, the relation was given as this. 1 over n is equal to the square root of k squared plus a squared all over hg. Now, once we are making the variable the subject, and this involves a square root, whereby the variable we are interested in is in the square root, we are going to square both sides so that we can get rid of the square root. Now, squaring both sides will give you this side squared, this side squared. Now, the square will cancel the square root, leaving this behind. Then the square that we have here is for the numerator and it is also for the denominator. So 1 squared is 1 and n squared is n squared. Now from here, you can see we have a what? A fraction. Now we have to get rid of the fraction by multiplying each term by the LCM. We were told that if the denominators happens to be variable, find your LCM by multiplying the denominators. So n squared times gh will give you n squared gh or g n squared h. So we multiplied this term by the LCM, which is this, and also multiplied this term by the LCM. So the n squared cancel the n squared, giving us gh times 1, which is this expression. This is equal to this term being multiplied by the LCM, gh cancel gh, leaving behind n squared times this. Now because the n is going to multiply this and this, we just put this in a bracket so that we don't only use this for this, leaving this one behind to make the work wrong. So now that we have this multiplying this will give you gh. N squared times a squared is this. N squared times a squared is this. Now that we have this, we now have 3 terms in the expression, making k the subject. So the term with the k should stand alone. So we grouped like terms. So we have k squared, n squared, k squared is equal to this, or this is equal to that. But the n squared is multiplying k squared. So we have to divide both sides by n squared. So we divided this by n squared. We divided this by n squared. So n squared cancelled n squared, and this being divided by n squared. Now you have this. K squared is equal to this because we have divided this side by n squared. But we want k, not k squared. So what did we do? We therefore square root both sides so that we can get rid of the square in order to let the k stand alone. So we square rooted both sides and the square cancel the square root. Then this one is now in the square root. But this being in the square root is for the numerator and also for the denominator. So we separated them to get the square root of gh minus n squared a squared all over the square root of n squared. So the square on n here will cancel the square root. And we were saying that we cannot say because there is square here, so one of the squares should cancel the square root. No, it can't be done that way. So let's put this in a bracket. It can't be done that way. But therefore, we can do to get the k to be this. So now we have been able to express the k in terms of the other variables. Now the question says, hence find k. If n has been given, a has been given, h has been given, and g has been given. So this is where the substitution comes in. So you now have the square root of g. What is g? 32. So 32 times h. H is 2 minus n squared a squared. So n is 8 over 5. So squared. And a is 3. So also 3 squared. All over n, which is 8 over 5. So now we have substituted. So this is g, this is h, minus n squared times a squared, all over n. Now let's take our time and solve the numerator. Now when you solve the numerator, we are going to have the square root of 32 times 2 is 64 minus 8 over 5 squared. The square is for 8 and the square is for 5. So we are going to say 64 over 25. Why 64 over 25? 64 over 25 because 8 squared is 64 and 5 squared is 25. Now times 3 squared, which is 9, all over 8 over 5. So let's solve it systematically. Now in the square root, we are to apply board mass. You have 64 minus 64 over 25 times 9. Now, using board mass, multiplication should be solved first before subtraction. So we are therefore going to multiply 64 over 25 times 9. And this calculation can roughly be done here as times 9. Now when you multiply 64 times 9, you should get 57.6 over 25. So that would be 576 over 25. That is the multiplication for these two. So now that we have the answer, we are therefore going to say that this is equal to the square root of 64 minus 576 over 25 all over 8 over 5. So we are solving it systematically. We are not in a rush so that we don't get any mistake for the examiner to penalize us. So we are applying the board mass. You multiply before you subtract. So now that we've multiplied, we have this. Now we are going to subtract this from this. So using the idea of subtraction of fractions. So we have 64, which can be taken over 1, minus 576 over 25, all over 8 over 5. So here, solving the numerator. Remember, it is in a square root. So we keep on repeating the square root till we are okay without the square root. So now, LCM to be 25. Now, 1 will go into 25 times. Then you multiply 64 times 25. 64 times 25, and that should give you 1,600 if you should multiply well. 64 times 25 should give us 1,600. Yes, we are correct. So we have 1,600 minus 25 will go into 25, 1, and 1 times this is 576. Now what do? We subtract the numerator. So 1600, 576. So you subtract, you borrow 9, 10, 4, 2, 0, 1. So subtracting the numerator, you now have the square root of 1024 over 25 all over 8 over 5. Remember, in basic 9, calculator is not allowed. So you have to work this out using your table. That is your what? Your multiplication tables. Very, very important. So here, we multiply to get this. So now we multiply this to get it. You know that in multiplication of fraction, you don't find LCM. The whole number is taken as over 1. Whereby you multiply the numerator times the numerator, then the denominator times the denominator. So from here, you subtract. This is also taken over 1. LCM is 25. 1 here 25. 25 times this will give you this value. Then 25 here 1 times this will give you this value. Then you subtract. When you subtract, you have this. Now we are going to make the use of the square roots now here. Now what is the square root of 1,024 over 25? Now because you are not using a calculator, just relax. Know that the square root is for the numerator and the square root is also for the denominator. So we are going to break it down so that we can solve this as the square root of 1,024 over the square root of 25 all over 8 over 5. That is the meaning of this. So the square root is for the numerator and the square root is for the denominator. Now look at the value here. You are not using a calculator. So how can I know that there is a number times itself? That will give you this. Now if you are someone who knows your square numbers to the extent of knowing huge values, you should be able to know that 32 times 32 will give you 1024. But if you don't know, look at 30 times 30. 30 times 30 is 900. So you are getting close. So now go to 31 times 31. When you multiply, you know that you are also getting close. Now when you multiply 32 times 32, you have this value. So the square root of 1024 is 32. Then the square root of 25 is 5, which is all over 8 over 5. So now, you have been able to solve to the extent that you have simplified it, having a fraction divided by a fraction. And we can write this as 32 over 5 divided by 8 over 5. This expression, 32 over 5, all divided by 8 over 5. We can write it as this. So 32 over 5 divided by 8 over 5. What were we told if you are dividing fraction? This changes to multiplication, then you reciprocate this very fraction. So you now have 32 over 5. So 5 will cancel 5. 8 here 1. Then 8 into 32 4 times. So you now have 4 times 1, which is 4. Then 1 times 1, which is 1. So our final answer for K is therefore K is equal to 4. Because remember, all these that we are solving for K. Because the question said find K. So K is equal to what? 4. And that is what you are supposed to do. Remember, this question is having 2 commands. You have to make K the subject, then you substitute. So making K the subject, you go systematically. You have been taught how to make a variable the subject involving square roots. Apply. You have been taught how to make a variable the subject involving fractions. Apply. You have been taught how to make a variable the subject in relation involving brackets. Apply. Square. Apply. Then you have it there. Then when it comes to the substitution, you take your time, you solve it systematically. There is no calculator for you, so you have to take your time by knowing this common multiplication and division of numbers. So dividing everything and working out, the value of K is equal to 4. Thank you very much for staying tuned. If we speed, we apologize. We'll write more description or more explanation on this at the description button so that you can understand it into details. But we meet next time, God willing, we will look at factorization of expression or how to factorize expression. Thank you very much. If you have any contribution, you can leave it in the comment section. If you have any question, also do same and we will attend to you. The name is Christian. Please don't forget to subscribe and also share the link to other people to benefit. Thank you very much. Bye-bye.